Hello, and welcome to Teach Engineering. My name is Ariana, and I am currently a junior at the University of Colorado Boulder, studying to become a biomedical engineer. Look around the classroom. What do you see? Desks, walls, air, people? Well, what makes up all these items? They all consist of matter. Any item that has mass and takes up space can be considered matter. Whether it is the solid surface of a desk, the air we breathe, or even our bodies, everything is made up of matter. Now, let's dive deeper. What are the basic building blocks of matter? The answer is atoms. Atoms are the fundamental units that make up matter. Sometimes atoms bond together to form molecules. A molecule is the smallest part of a unit that retains all the properties of a substance. For instance, a water molecule is made of 2 hydrogen atoms and 1 oxygen atom. Some molecules, like those of helium gas, are made up of just one type of atom. Atoms might be tiny, but they hold tremendous power. The atom structure. So what exactly is an atom? An atom consists of 3 basic subatomic particles. Electrons, negatively charged particles that spin in shells around the nucleus. Protons, positively charged particles found in the nucleus. Neutrons, neutral particles also found in the nucleus. It's easy to remember. Protons are positive, neutrons are neutral, and that leaves electrons with a negative charge. Now, where are all these particles located? The electrons spin around the nucleus of the atom in orbits or shells. The nucleus, which is at the center of the atom, contains protons and neutrons. Understanding the structure of atoms is crucial for engineers and scientists. They use this knowledge to develop new materials, such as non-stick coatings for frying pans, safer football helmets, and carbon fibers for faster cars. They also harness atomic energy for electricity and create advanced machines like lasers, which have applications in the medical, dental, and industrial field. The more we learn about the makeup of matter, the more possibilities we unlock for future technologies. Many ideas from the old series of Star Trek are becoming real as scientists and engineers discover more about atoms and their potential. The Greeks were the first to get the atomic bomb rolling. Democritus theorized that matter was composed of tiny, invisible pieces. Leucippus introduced the term atom, meaning indivisible in Greek. However, they had no way to test their theories, so the concept of atoms remained just a concept for almost 2,000 years. Fast forward to the 16th century, Robert Boyle introduced the idea of elements that couldn't be broken down any further. Then, in the 18th century, John Dalton proposed that these elements might be made of atoms, setting the stage for modern atomic theory. Generally, the number of protons and electrons in an atom balance out, making the atom electrically neutral. Electrons are the furthest from the nucleus, are called valence electrons. Those are the ones most easily shared or transferred to other atoms. Atoms missing an electron or sharing an extra electron become ions and readily combine with other ions to form molecules. The number of protons in an atom is known as the atomic number, determining the element. Within an element, the number of neutrons can vary, creating different isotopes. These isotopes have similar chemical properties, but can differ in mass, affecting how quickly they react. Modern understanding of the atom. Traditionally, the atom was visualized as a miniature solar system. Today we understand that if we could see an atom, it would look more like a fuzzy cloud. Using probability theory, scientists can predict where an electron might be, but its exact position and momentum cannot be determined simultaneously. The scale of subatomic particles. To give you an idea of scale, an atom is about 1 times 10 to the negative 9 meters in diameter. The nucleus is between 1 times 10 to the negative 15 to 1 times 10 to the negative 14 meters. Protons and neutrons are around 1 times 10 to the negative 15 meters. Electrons are much smaller, around 1 times 10 to the negative 18 meters. Imagine this. If we scale up an atom so that the protons and neutrons were each a centimeter in diameter, the atom's diameter will be larger than 30 football fields, with electrons being smaller than a hair's diameter. Remarkable! 99.9% of atoms' volume is just empty space. Subatomic particles and beyond. Physicists have discovered even smaller subatomic particles, such as quarks, leptons, neutrinos, and bosons. However, for our everyday understanding, we focus on protons, neutrons, and electrons. The atom still holds many mysteries. In the last 100 years, we have made incredible discoveries about how atoms behave, but there is still so much more to learn. For instance, think about how different the world was when your parents were growing up. They didn't have some of the technology we take for granted today. Advancements in particle technologies, such as the use of lasers, have been game changers. Engineers have utilized the atomic discoveries made by scientists to create devices that improve our lives and advance society. To better understand atoms, look at the entire lesson on the Teach Engineering website and check out the associated activity, Gum Drop Atoms.